Hi, I'm Victoria from Kingspan Insulation. We're just waiting for the last of our numbers to load in today for our webinar. So it just takes a moment sometimes for everyone to load in, and if we start too early, it means that we can have a little bandwidth, as you know, on these things. So we're getting up there on numbers now. So I might just kick off. So welcome to the first Kingspan Digital Academy for 2026. Today we're going to explore the topic of bracing in a building, how it works, how Kooltherm K17 Insulated Plasterboard can help designers and engineers meet their requirements for bracing. To help me with the topic of bracing, I have Russell Pedersen with us today. He's the Technical Support and Training Manager for Winstone Wallboards. And as we partner with Winstone Wallboards for the K17 Insulated Plasterboard product, it's my pleasure to have Russell with us today. Russell's going to be helping me with the chat on this today. So if you've got any Q&A, please just pop it into the chat, and we're going to have time at the end of the presentation to address your queries in detail. So just type them on in there and we'll go forward. There will be a recording of today's presentation, of course, provided out to you and all those that are registered, and you're very welcome to share that amongst people. So let's get kicked in. What are we going to look at today? The bracing units in construction, and we're going to introduce the new testing for Kooltherm K17 35mm insulated plasterboard. Now, with high R value rigid phenolic insulation on the back of the product and a 10mm GIB, this product is a simple way to renovate your home and offer thermal performance bracing requirements that you might need for your build. So what actually is K17 insulated plasterboard? It's a bonded product where the 25 mils of high R value rigid phenolic insulation is pre-bonded with 10 mils of GIB plasterboard. And so it is actually GIB, which is why we're proud to have GIB as our partner with us today. This gives us a 35 mil thick board and a whopping R 1.15 thick, R value for the board. So we're giving thermal performance as well as a final interior finish with a Group 1S rating. This product's ideal for renovation and for new build, and we see it commonly in renovations where we're looking to perhaps add some thermal comfort to the building. It is fully supported by an environmental product declaration, and it's made in our Australian plant with a global green tag class C as well. And of course, we're on all the platforms you'd expect to see us on: Master Spec, Smart Spec, and so on for specification. The key question that everyone always wants to know is, how much is a wall system going to cost? And Maynard Marks did a modelling of cost variations for us for various wall constructions, just using standard merchant and labour rates. You'll see here in the bottom of the modelling example that they used K17 35mm, providing a very thin wall structure, so 145 millimetres, with a continuous layer of insulation on the inside of the frame. That with an R 1.8 bulk in a 90mm timber frame, and we did use 30% framing for our initial modelling, we had an R 2.84, so really high R value, offering a lot of flexibility in the design. It came in at $175 a metre squared, but being a very thin wall construction, that gave us a lot of internal space back in our build. Even if we did increase the framing percentage to 38% in line with the proposed H1 changes, we're still getting a great 2.73 R value out of that wall construction. So very useful. Let's look at some key bracing terminology today that we're going to use from the GIB handbook, because I've mentioned we are part of the GIB family here. So bracing distributes the lateral loads throughout the structure, reducing the stress and limiting damage during wind or seismic events. A bracing element is the line section of wall that is fixed to a specific pattern to resist those loads, and that gives us the bracing units, the measure of the wall's strength when fixed to those patterns. And that's often defined in terms of standards like 3604. The GIB standard is when that specific perimeter screw pattern is set in place. But we can augment the bracing units that we get out of a GIB standard by adding some handy brakes or some other supported bracket that will give more bracing units to that wall. And finally, the fastener pattern is critical. The bracing units are achieved by the specific fastening pattern that has been tested. So for any particular unit, you must follow the fastening pattern that's laid out for that particular product. We're going to talk more specifically about the bracing units and the fastener pattern for K17 as we move through this presentation. If we look at the physics of bracing, there are two main forces that are acting on the bracing element. There's compression and tension. And compression is a crushing force that pushes the materials together like squeezing a sponge. But tension is a pulling force that tries to pull the material apart like a rubber band. So here, when we're looking at bracing, we're looking at resistance to a load that might be lateral, such as wind or seismic, that's looking to both squeeze and pull apart at the same time. In practical terms, in a house, the beams and columns are going to work together through compression and tension, but primarily they're dealing with the vertical loads on the building from the roof structure and the weight coming down from there. The bracing elements that we might see, it might be K bracing or cross bracing, are designed to resist the horizontal load. So typically wind movement on a house or seismic movement on a house. We might see K bracing installed where elements such as windows and doors are in walls, but we might see cross bracing when there's a higher level of lateral restraint required, so higher wind zone areas or higher seismic areas. New Zealand Standard 3604, Section 5, provides guidance on how to determine the required bracing demand or capacity for light timber frame buildings. Designing the bracing is the responsibility of the structural engineer or the architect, and it's not a simple process. There's a lot to consider in terms of the factors. The key drivers are wind demand and earthquake demand. For buildings designed within 3604, the total bracing capacity provided must exceed the higher of the calculated wind or earthquake demand using the relevant table set out in the standard. There's an example of one of these tables here for the wind demand. In simple terms, the building must have enough bracing to safely resist the loads it's likely to experience. Now, we are going to touch on the new building standard a little bit later in this presentation, so we'll come to that as well. Determining the bracing, as we said, requires consideration of the wind and earthquake, but also of the region, the ground roughness, site exposure, what kind of ground it's on, subsoil, and so on, the shape and the size of the building impact, and again, cladding weights and live zones within the floor. BRANZ does provide some very useful maps that divide New Zealand into different wind and earthquake zones that will help an architect or an engineer determine the requirements for their area. And the territorial authorities also provide wind maps, which can be used to confirm wind zones. Or New Zealand Standard 3604 tables are very useful as well. Now, it's important to be mindful that increased wind requirements for buildings located in lee zones can affect the building design. Wind effects can be more severe in those locations. BRANZ, of course, have come to the party with some great literature around bracing design. And I've included an article here for your bedtime reading. This article is particularly useful because it illustrates clearly how bracing should be laid out within a building. The key principle being to distribute the bracing units evenly across the structure, rather than concentrating at the ends or only at the external walls. As we show in these images from that article, the direction of the wind across the ridge changes the location of the bracing units in the building. Bracing units are marked in lineal metre for wind and per square metre for earthquakes. The new building standard provides a relative measure of seismic risk by comparing the existing buildings to a modern code-compliant building, to the New Zealand Building Code. It's primarily used to assess the seismic performance of buildings with a view to looking at strengthening of those buildings to bring them up to the modern code. When we look at these buildings, we're generally assessing within two categories. One is between 34 and 67% of the new building standard. Buildings that fall within this category are generally going to have some additional strengthening added as part of other asset management interventions. A classic example would be a school, and the Ministry of Education has asked for all school buildings to be strengthened as near as practically possible to 67% of the new building standard. A school may look at doing some renovations on some classrooms, and at that point they will consider how can they add extra bracing units into that building. For buildings below 34% new building standard, strengthening should be prioritised. And in those cases, it's likely that a structural engineer will be employed because a standalone strengthening project will be required. K17 Insulated Plasterboard is a cost-effective and very easy install choice for architects to add bracing, insulation, and thermal performance to a building. In the example of the education classroom that might require some additional bracing, it's also going to add thermal comfort, and being fast to install will meet the construction timetables. Now, I just see Russell popping up on my screen here.
Hey,
So hi to Russell. I'm going to
sorry.
hand over here. No, it's good. I'm going to hand over to Russell. Russell's going to take you through the Easy Brace bracing software that GIB have created to make bracing a dream. I'll leave it to you, Russ.
No worries. Thanks, Victoria. Cheers. And sorry, I'm late. The great thing about the Easy Brace software is that um, it has the ability to do all the back-end calculations without having to do all the hard work. And so the other kind of really cool feature we've built in here is that you can create custom elements. So if you've already got the Easy Brace software package, you will have all the jib bracing elements. And the way that you can create, if you haven't used it already, to create a custom element is basically you go into the last tab on the bottom of the screen and it says custom elements, and then what Victoria's got on the screen here is you create the um, module, and in this example we've got a 0.4 minimum length, and then we've got the BUs for wind and EQ, the earthquake BUs, and so then you enter that all in manually, and then if you show the next slide, when you go back to the interface where you've got all your jib bracing elements, we've now got the custom elements entered in there, and you can just use them like you would one of your standard jib elements, and it has the BUs associated with it. So it's really easy interface to use, and we've had a bit of a talk about it, and we are going to, in the future, in the next update, we're going to add the K17 bracing elements in with the software package. Watch the space where we're kind of seeing how that's going to look. It may go online. Now, the other thing, and Victoria gave me permission to kind of mention this, but we've got this on the screen there. We've got the second kind of line in there. It says line A, B, C, and then the one next to it says external length. I Not in every case, but more commonly, you'll have the K17 bracing and insulative panel on these external wall sections. So it's really important that, and one of the things people get quite confused about with this column is the external wall length. Some people put in the overall building length on line A, for example, and that's great if it's a square box, but if it's only got part of the bracing line A as an external wall, you only put how much of that wall is external. So it might be a 15-meter long wall and only 5 meters of it is external, and or vice versa. It might be 5 meters, and so that's where you put in the external length. You put the number of meters that is an external wall, because that does change your output where it says 106 or 108 okay, because our goal is to create enough bracing units on that line to not just meet your requirement for wind and earthquake resistance, but it's also some building code minimum requirements for external walls. So and I guess that's, chatting with Victoria, that's where a lot of these insulated panels with bracing capacity will be used, because people are like, I need bracing, but I also need, and so yeah, that's kind of how we arrive down this track. But that's how you enter in a custom element, and it will show up on the screen
So
in your
this is
main
a
menu.
really, sorry, this
You're
is
all
a
good.
really way for people to show compliance for bracing just by using the software, because they
Yeah.
don't have to go through all those pieces of literature that I showed from BRANZ and the territorial authorities. They can
Mm,
just put
mm.
it in here.
And the other
Great.
thing as well is that because it's all in one document, you're not having to switch between one for JIB and one for, it's all on the same
Yeah.
interface.
So it'll make it easy for council compliance too.
Mm.
Great. Thank you very much, Russell. We're going to come back to Russell because I'm sure that the chat questions are going to be heavily on bracing units. So we're going to, with Russell as technical support manager, we're going to call in on his experience later. Thanks, Russ. So first, let's have a look at where the documentation is that you're going to need to be able to put that information into the software. Now you'll notice here I've got a QR code on the bottom of the screen. For those of you that are feeling tech savvy and adventuresome today, pull out your cameras, you'll be able to scan that and you'll be able to look at those reports as it'll take you directly to our website. But here on the K17 on the Kingspan Insulation website, kingspan insulation.co.nz, you'll find that we have both a supplementary report and a testing report. Now, the supplementary report, oh, look, there's that QR code again. You can still scan it. This supplementary report is on the left-hand side. It's basically a summary document. It gives you the short, sharp version with the fixing pattern that is so important, but of course, the bracing units that you can use to put into the calculator. The image on the right-hand side of the screen is showing the testing for the K17. Now, because our code mark appraisal for K17 does not include the bracing elements, having the testing gives you an easy pathway for compliance with council, but it also gives you the extra information an engineer might need to help them with their bracing requirements. So both those are on there. K17 was tested with GIB, thank you very much, to a P21 bracing test. Now, that's where the K17 is directly fixed to the structural base, and then testing is completed with the GIB handy brake and without the GIB handy brake to establish bracing units for every scenario. We also did several different widths of product to enable you to look at these bracing units across your build. Then a hydraulic arm is attached to the top of the structure, and basically it moves it to simulate that lateral movement, that bending moment that we might see with a wind or a seismic event on the wall. You'll see there that the handy brake has been correctly installed with the blue Bomax screw as per the GIB specifications. But I think GIB also have other information on other proprietary hold down systems that I've got their contact details at the back of this presentation. You could have that discussion with GIB directly if you wanted to chat about other proprietary and the test results there as well. So once we got those test results out of these, we were able to publish our data for the bracing results. Now, each panel width was tested, as I say, to give you scenarios for your type of build, and we did an average of 3 tests for each panel width, which are published there. So bracing for wind, for earthquakes, the size of the board, 400, 600 or 1200 that was tested, and whether a handy brake hold down was used or not. So you get some images for your wall. We did actually test the full range of K17 phenolic insulation boards across a variety of thicknesses to really see if we could look at the thicker insulation giving much higher R value for that structure, or whether we needed to stay in the thinner ones. Now, we chose to stay in the 35 mil product, so 25 mils of phenolic and 10 mils of GIB, because the phenolic is not a particularly rigid insulation product. And this enabled us, with the fixing pattern specified by GIB, to give a good amount of bracing units in relation to the amount of screws that we use. If we had thicker phenolic insulation, we found that we weren't offering valuable bracing units in relation to screws, so we're only publishing bracing for the 35 millimeter board. The bracing pattern for K17 35 millimeter is very similar to the standard bracing pattern for GIB at 50, 50, 50, 75. But where we differ is where a standard GIB board would now have 150 mil spacing around the perimeter of the bracing unit. K17 stays at the 75 mil spacing for the fixing as you move around the board. Now, that is because we're accommodating the phenolic insulation to give those bracing units. As per standard, the screws are 12 mils away from the bound or tapered edge of the board and 18 mils from the cut edge. This is a product sample, so every edge is cut, but generally the K17 boards will have 2 bound edges and 2 cut edges, as you can imagine with the GIB coming off the line. So how do we compare? Well, actually, we compare quite well. The K17 board with hold downs actually gives us slightly more bracing elements than the GIB standard plasterboard without hold downs. But we're also adding, remember, R1.5 of insulation and the opportunity to mitigate thermal bridging using the K17. Naturally, of course, just like GIB, because it is GIB, the K17 has a Group 1S rating. So let's look at bracing requirements for renovation. A key principle of New Zealand Standard 3604 is that lateral loads must be evenly distributed across a number of relatively close-spaced building elements arranged on bracing lines. So you can see here in this diagram, we've got bracing line A, B, C, D, M, N, O, P, Q as it goes down. So in this example, our clients have wanted to increase the door width. And so now, because they've removed some bracing elements out of that bracing line, they need to consider how that's going to be put in. So they need to add additional bracing lines. As Russell mentioned, some of the concerns we might have here are on the external walls where bracing lines need to be added, but we're also thinking about the thermal bridging. Now, we know we've got extensive timber framing within these corners because now we're supporting a wide door as well. And there just quite simply is not enough room in these areas to add insulation as well. So the disappointing experience for a homeowner may be that they get their beautiful wide door, but suddenly that's a very cold corner of the room. Using K17 on this wall will actually give you the bracing units that you require, but it'll also mitigate those cold timber framing areas where there's no insulation, mitigating that thermal bridging and giving you the experience that you were looking for out of your renovation. Now remember, the new braced wall element should be located on the same bracing line as the bracing element was removed. So now how do you calculate those? Well, the P21 test is used for elements within isolation. When we look at renovation, we're generally looking at bracing units that are part of an integrated system. So the P21 test doesn't quite calculate across like for like in terms of renovation. You need to be a little bit of a detective. So as you're just deconstructing your wall, you need to be noting what the current wall construction is and find a way to be able to determine those bracing units. Yes, your structural engineer might be able to help you, but also this BRANZ study report is very useful, showing older generic wall type constructions that you could use as a comparison or a basis for discussion about what the bracing units might be in the existing wall and then how you're going to replace them with your renovation design. Again, you might not need consent, but you have to replace the equivalent amount of bracing units that you've taken out in your wall, or perhaps even provide more bracing units. Where insulated plasterboard has been used over products such as CLT or Lockwood walls, these are considered non-3604 types of construction. In those cases, the bracing design would need to be completed by a structural engineer. But from a renovation perspective, these buildings can be hard to renovate to add additional insulation. And there have been some anecdotal examples of these being perhaps some creaky buildings and so on, even though they are very well braced in engineering. You will need to get the plans for your particular Lockwood, for an example, from council and so on, because they do have extensive bracing designed into them, and you'll need to understand that for your building. But if we look at providing insulation and some additional bracing to the building, it's very easy to do so with K17. It can quite simply be attached directly onto that original Lockwood wall, giving a nice bright white finish. And of course, the window reveal just gets built out to accommodate that extra insulation and new GIB thickness. It makes a very simple and quick installation, and you can see it can be used for both the ceiling and for the walls. And the nice bit is it's so easy to cut it out. This is an electrical cable that we've cut out here, electrical cable box. I can run my cabling through the back of the K17 just simply by chasing out an area, because the phenolic insulation will not plasticize the cables as an expanded polystyrene product will do. So now I've got a lot of flexibility in my design and very easy to replace and create a new finish with thermal comfort. We can also use K17 insulated plasterboard for examples as we're seeing here on screen. Now that left-hand example is a classic steel framed house where it's got shadowing coming through the GIB, thermal bridging showing through. In this instance, being able to lay a continuous layer of insulation on the inside of the building mitigates that thermal bridging from the steel framing and adds thermal comfort. If you recall, it's R1.15 for that product. It can add bracing units as well if that's required for that building. For the image on the right, the key principle is that we need to have sound plasterboard if we're going to put the new K17 over it. And this is moldy plasterboard. So in this instance, we wouldn't consider that sound. It would be removed from the building and the K17 would be reinstalled in its place. Again, a very simple and quick option, adding thermal comfort and a lot faster than trying to do some pocket insulation methods as well. But your question might be, if I put K17 back in that application, am I going to perform better than the mold affected plasterboard? Have I actually resolved the issue in that instance? Yes, you are actually. It's going to be a lot better. K17 has been modelled as part of our white paper for timber framed wall constructions and mold growth risk. Now, again, another QR code for you. You can just scan that QR code with your camera and you'll have access to that. And what this will show you is a variety of both conventional construction and continuous in construction that have been WWOOFy modelled in both Auckland and Dunedin for some climate zone comparisons throughout New Zealand. Now, what we were principally looking at here was looking at continuous insulation solutions in terms of the mold risk that might be present. And you can see in the diagram on the left-hand side, using K17 as an internal lining to a timber framed wall with just a simple R1.8 bulk gave us an absolute pass in terms of mold growth. How does it work? Well, it actually reduces the amount of moisture that is diffusing into the timber frame. It lowers the relative humidity within the frame, and as a result, it reduces the risk of mold. Now, even though the timber frame itself remains relatively cold, this will still meet a zero mold growth. So we're very happy with that result. It is very important to note that different wall constructions will produce different mold growth risk profiles. So I do invite you to take time, have a cup of coffee, read through this paper and look at what you can find in there that relates to your project. And of course, you're very welcome to call myself, my team, and we'll be able to discuss this with you in more depth. So to summarize today, when we're looking at bracing, we're looking to resist the horizontal loads or the lateral loads that are impacted on a building by wind or earthquakes. We need bracing elements to do that, to resist the compression and the tension at the same time. And the recent tests that we've done for K17 35mm plasterboard have shown that we can add bracing units and value to a building that requires bracing for renovation or new build. We know that K17 will provide thermal comfort to the occupants. It will mitigate thermal bridging, improving the overall insulation performance of the building and adding those critical bracing units for new builds and renovations. If you need help with your project, you've got two great teams. You've got my team, technical at kingspaninsulation.co.nz, but of course the GIB helpline team, sitting with Russell, chair for Russell, will also help you all there. Now, I did put the QR code for the K17 supplementary and test report there online, but now, and I'll just flick to that page, we also have a lot of bedtime reading for you that we used as the basis for this presentation. So please, when you come through there, you'll be able to look through there and see some of the literature that we found so interesting. Now we're going to throw open our chat line and address your questions that you may have. Russell's going to lead me away.
Yeah. So, thanks, Victoria. And so if you use the chat function down the bottom, we'll do our best to read them out and answer them. So flick them through now. And I was hoping for some easy questions, but the first question on the list is it's had me scratching my head already. And I was texting the engineer out the back asking the question. I haven't had a reply yet. I was really hoping people would be nice and gentle with us, but so I'll read out the question, and I don't know the answer, but it's a good question, and I was Googling furiously in the background. But someone's posted the question saying the BRANZ study report SR337 2015 recommends that seismic bracing demands determined according to NZ3604 need to increase by 50%. This means that an easy brace earthquake resistance should be 150% minimum. So the reason why I text my engineer is because I've never heard of that before. And the report 2015 is obviously 11 years old now, and I have never come across this before. So good question. It's going to take some reading because the report is 100 kilobytes, so it's a lengthy report. And I don't know the answer yet, but all I know is I've never been asked that question before. Usually people arrive at about 125, 130% minimum on their calculations anyway. But yeah, I've never heard that before. So sorry, I can't help on that one, but
I always like one out of the box first off that we can't answer.
Well, I was, hoping for something easy, like what length screws and that kind of thing.
Well, now you've
The
got your bedtime reading there, Russell.
Yeah. Well, the report does mention SED, and it does talk about ultimate limit state versus service limit state. So there's a whole conversation around that anyway. But yeah, so yeah,
Okay.
if you've got any other questions, I can't answer that one. Sorry, but it's a very
I
interesting
might throw
one.
you a curly one as well.
Please
I
do.
was asked recently about what testing we had for other hold down type products, other proprietary products other than GIB. Now, of course, we like to support, and we have tested with
Sure.
the GIB handy bricks. What support can the GIB helpline team give us with regard to other proprietary hold downs?
Being aware that our marketing team will be watching this too, so I've got to be careful what I say. But we produce what we sell Jib Handy Bricks as a complete solution, and I was looking through, and in our site guide we show the standard approach of on page 70 of the site guide, where we talk about using the traditional strap and bolt with the square washer arrangement. So you don't have to use a handy brack. Hold downs are generally, and the terminology is generally left open for other products, and generally understood that you're going to need 15 kN hold down into a concrete slab, and 12 into timber. And so if you can achieve that and prove that you can achieve that, then essentially there'll be no change to the bracing units determined by the jib test. And so our goal is to test with and without handy bracks. And obviously you'll notice that the handy brack has most use for where we have our earthquake. And that's because we've found that when an earthquake happens, it's not just shaking like that, it's rocking like that too. And so that's where the handy brack comes in. Now, you mentioned proprietary or other brands. We have tested and used other brands just because we're interested to see who's making what. And there are other brands out there. I can't give you our test results, but I can put you in touch with whoever from that company will have the information. And, in saying that, sometimes the inspector will come knocking on the door, and it's sometimes just easiest to stick with the brand that's on the bit of paper. But yeah, again, we're not here to shut the door on anyone else. So yeah, we can help that conversation.
Yeah, thank you very much. That gives us some versatility in the market, but we do appreciate that we do have some very complete testing with
Yeah.
GIB in the GIB system. And this is a GIB plasterboard on the front of the K17 as well,
Yeah.
as we mentioned before. I don't think we've got very many questions on this
Yeah,
today.
I just saw
Have you got
one
what?
come
Have I
through on the
missed?
chat.
There,
No, there was one on the
there's a
chat.
few in the
Oh,
chat. Sorry, just wanted.
okay.
A question is, do you need a building consent if you remove wall linings?
Well, that's an interesting conversation. If we were going to remove the wall linings and add insulation within the cavity, typically you do need a building consent. To put the K17 over the interior of the plasterboard, I don't believe you do, but it's always advisable just to check. Russell?
The grey area is what's allowed under maintenance. And
Yeah.
so if you're maintaining or you're repairing something, then you can replace standard plasterboard without. But the question comes down to, like you say, Victoria, the insulation requirement. So generally, if it's a repair to an older home with no insulation, you're strangely enough not allowed to insulate outright. And so we obviously, if it's a bracing element, you're having to replace that. Yeah, that's that whole conversation of restricted building work. And so yeah, it's interesting because we've got a minute, so I'll just mention it. But the after we had all those floods, there was a certain amount of work that was carried out under the emergency works provision, and that meant that you didn't have to get consent for things like if you did a repair to a bracing element. In that scenario, my house flooded and when we lost, like a meter of board, and they replaced that kind of meter or 1200 up. And they didn't apply for consent. They didn't lodge it. They just documented it and submitted that. And so, yeah, there are scenarios where you can, if it's like that emergency clause. But generally speaking, if you're just doing a renovation and you're replacing jib plasterboard, then yeah, you don't need to worry. Bracing elements, you do. insulation you do. And I kind of a plug for your product is that that's where we get people saying, well, actually, I'm going to leave my existing plasterboard there and I'll put K17 over the top. Or take off the board and put K17 on, because that way you technically aren't adding insulation into the cavity. So
I looked at it for my house. I have a 1980s house, no insulation in the walls, direct fixed cladding, and that jib with the silver lining. And so it would be a product, yes. So that would be a product I would put the K17 on the
we're
internal
not allowed to
side of
talk
that
about
existing.
that.
Yeah, no, we won't. Okay, there's just a couple of questions, and I'm cognizant we're a little bit over time. Yes, there is estimated meter squared cost for not only a K17 wall construction, but other wall constructions in this presentation. So we're looking at about $175 per meter squared on a 90mm timber framing with an R1.8 bulk. You're going to get a recorded copy of this presentation, so you'll be able to check all those figures for all the different wall constructions. They were done by Maynard Mark, so an independent based on very standard merchant and labour costs. So I'm pretty sure your builder's got a better pricing than a standard merchant price, but it gives you a ballpark between the wall constructions. Don't underestimate the value of increasing the floor space within a building by having a thinner wall construction. It's often a lot more than a little bit more on that wall construction price. And can the board be used as a RAB board? We are not a rigid air barrier for K17. While we do restrict the movement of vapor within the board, it is not an air barrier, and it is on the internal side of the frame, so not an external side. If you wanted a rigid air barrier board, of course, there's plenty of proprietary products on the market, or you could use fibre cement or plywood and our Rain Armour flexible underlay, which is BRANZ appraised and is an air barrier, which will turn that into a rigid air barrier.
Good
And I
question,
think
though.
it is a good question. We're happy to discuss that. The technical teams are still on screen, I think. If you need GIB or if you need Kingspan, we're all here and happy to help you with your project. Thank you so much for your time today. Thank you, Russell, for coming. I'm looking at you because they're on that screen. Russell, for coming and
Thanks.
joining us today and adding your
Thank you.
expertise there. And thank you for the technical team, Marie and Pedro, who are also online, adding expertise and help in the back. We look forward to seeing you throughout the year with our other digital academies. Thanks for joining us today.